Welcome to part 3 of Foundations Math 30.7, where we're going to be talking about sinusoidal functions. So sinusoidal functions are kind of funny, well, not funny, but they're actually quite useful because we actually deal with a lot of different types of sinusoidal functions, mainly anything that's periodic, and we'll talk about what all that means. But a lot of the characteristics and being able to determine things between equations and what their graphs are going to be very similar to what we had done with the polynomials and the exponentials and logs. Criteria, being able to really understand your sinusoidal functions. So first one, before we get into an understanding of the sinusoidal functions, we're going to talk about a different unit of measurement. We're going to be talking about radians. Now, radians are basically it's the radius of a circle measured around the circumference. What I mean by that is we use what's known as unit circle to help with that understanding. So first off, what we're going to do is if we measure exactly what the radius is, now I'm going to have to do it a little bit, I'll have to measure it as best as I possibly can. But if I measure this radius around the circumference of the circle, one radius would put us approximately there. So that ends us with one radius. If I go one more radius, that would put me, let's see, approximately there or so. So that's two radiuses. A third radius will put me about, we'll say about right there. Next radius, be about so. The fifth radius give us to about right there. Add red next. Another one will put us to approximately right there. Now I know that's not perfect, but what we need to know is kind of approximately what that would be. Now if you do an approximate, if you kind of measure everything, I kind of measure that out, it's about 0.3 of a radius. Specifically though, it's actually 0.283185307 of a radius. Again, well, not exactly because the decimals would keep on going on. So meaning 360 degrees would equal would equal approximately 6.28 radians. Now the symbol for radians is the R. It doesn't necessarily need to be written because if it's not written, then it's already implied that it is the radius. But 6.28 is actually again, it's approximate, but there's some other things that we need to come to an understanding of. For example, right here, this little space in here is also a specific number. It's 0.14159265358979323846264. Well, if you've had enough classes with me, you'll notice that that's pi. That's 3.14159265358979323846264. That's exactly how many radiuses. So 180 degrees is actually equal to pi radians. More specifically then, 360 degrees will be 2 pi radians. So we're not even going to use this approximate. We're going to use the exacts. Now, it doesn't matter which one you do, because they're both saying the exact same thing. Now, just as a fun fact, when we were working with our units, degrees in radian, or degrees in previous years, so grade 10 and grade 11, we had made sure that we had to keep in degrees. So now we have what's known as the radians, which is actually that RAD on your degree radian gradient button. So fun fact, your gradient, which is the grad, is actually 1/400th of a revolution. So instead of 1 degree being 1 degree is 1/360th of a revolution, a gradient splits that into even smaller sections. So that's just a little fun fact. All right. So what we're going to do is we're going to calculate the value of each of these angles in radian measure. Well, that means we're actually going to use these conversions. I preferably stick with the 180 as pi radians because it just works out a lot nicer. You also don't have to do as much reducing. If I want to convert 90 degrees into radians, well, I'm going to do a conversion. 90 degrees. And I'm going to set up a dimensional analysis. 180 degrees is pi radians. Well, the great thing with dimensional analysis is our units would cancel off. At the same time, 90 and 180 reduces to be 1 and 2. So 90 degrees, 1 pi, divided by 2 radians. Of course, another way of writing that is just pi over 2. You don't necessarily need to write the R for radians, because if there's no unit stated, it's implied that's radians. We can do the exact same thing for 272. Setting up our dimensional analysis, the 180 would have to be in our denominator. Our pi would then be in the numerator. Once again, our units cancel off because numerator and denominator. And the 272 and 180, what's a number that goes into both? Let's see. Well, apparently my mind's not working the greatest right now, so let's divide it by 2 first. So 90, 272 divided by 2. Oh, too many things on my calculator. 336. Well, I know that those can reduce even more, so I'm going to reduce them again. Divided by 2. Get 68. Factors of 45 are 3, 3, and 5. 68 is not divisible by 3s or 5s. So we actually have everything reduced right there. 68 pi over 45. And the last one, 690 degrees. Using the same dimensional analysis, setting up our 180 in our denominator. Oh, make that actually look like 180. Sorry, I gotta erase that. That does not look good. Let's see. Should be able to divide them by, let's see, that's divisible by 3, that's divisible by 3, divisible by 30 at least. So 180 divided by 30 should be 6. And 690 divided by 30 is 23. Great. So we would have 23 pi over 6. Or, of course, 23 over 6 pi. Now, these would be exact values. All of these would be exact values. If by chance we wanted to have them as a decimal, all we'd have to do is take pi and divide it by 2. We'll go to two decimal places. 1.57. So that's saying that 90 degrees, which is right here, works out to be about 1.57 radians. That works out. Let's see, 272. Well, 272 would put us about just on the right-hand side of our y-axis over here. So it's going to have to be 5 point something, and it's probably on the higher end. So if we took 68 pi and divided by 45, oh, sorry, not 5, 4 point something. And yeah, it comes out as 4.75 radians. Yeah, 5 would be putting into here. Wow. All right, 690. Well, 690 is one full revolution and then another partial. Let's see, would put us about back to here. So we'd have 1, 2, 3, 4, 5, 6. A seventh one would put us about here. 8, 9, 10, 11, probably around 12, maybe a little bit more. So let's check it. 23 pi divided by 6. Oh, yeah, it's just over. It's 12.04 radians. Again, you can write the R, you don't have to. But that's converting from the degrees into radians. We can do the exact same thing from radians into degrees. For example, 5 over 6 pi. Now, that's the exact same thing as saying 5 pi over 6. So if I set up my dimensional analysis, I'm just going to have my 180 in the numerator. I'd have my pi radians in the denominator, because that will allow me to cancel off the pi's. And let's see, 5 times 180, 900 divided by 6 should put me at 150. Yep, 150 degrees. So this 7 over 6 pi will be 7 pi over 6. And this is just another way of doing it, just because it makes it a little bit easier for the cancellation. So once again, pi's will reduce. This should come out as 210 if I'm doing my math correctly. Let's check with the calculator. 7 by 180 is 1260 divided by 6, 210. And our unit is degrees because that's the one that's left. 13 pi over 12, 180 degrees, pi. So pi's reduce. Let's see, I'm usually used to 6, so we'd have 195. 13 times 180 divided by the 12. Yep. 195 degrees. Fantastic. And that's converting from the radians into degrees. So just going back, 5/6 of a pi. Well, we know that one full pi is this 180 degrees. So 5/6 of it will be about right there. Yeah, that's about 150 degrees. It's actually exactly 150, but comes equal comes out. Okay, which is bigger, 3 pi over or 8? Well, neither of them have degrees on it, which means that they're both in radians. 3 pi, this is just really nice and basic, is 9.42. So which one is bigger? 3 pi is. Alrighty. So that's just the introduction of our sinusoidal, talking about what radians are. Go have some fun.